We have somebody very interesting coming on stage next. He's a former artist and high-stakes poker player. So interesting. Now he's like rocking Bitcoin. He's the founder of the Mesos multi-sig wallet that's optimized for collaboration. He's also working with Galoy, and he's going to talk to you all about, is Bitcoin ready for the cloud? Please welcome Mr. Justin Carter. Woohoo!
Thank you. All right. Hello, everyone. Justin Carter, working for Galoy. Thank you for the introduction. We'll be talking about, is Bitcoin cloud ready? Now, this isn't going to be like some bombshell talk here. Fairly obvious stuff that I'm putting out, but I would just like to spread awareness to motivate people in the community to think a little bit about when they're building their software, is it appropriate to be adopted for use cases where scale makes a difference. So yeah, section 1, context. Reasons to build in the cloud. This is like what people generally want to achieve when they build systems that are meant to be operated in the cloud. They want to reduce the operational burden because it's other people's infrastructure. You don't have to deal with hardware or VMs. Everything is behind an API that you can automate. Ideally, you want to be able to scale your system dynamically so that you don't have to worry about when there's a surge of people wanting to get to your system because the infrastructure is just there and can handle it. Ideally, the system will also be highly available so that it can deal with any issues of the underlying infrastructure. If something goes away, then it can just fail over to another standby system or whatever. Ultimately, it's about the better end user experience. We want our end users to have high uptime and have a good experience when they're using your product. But this doesn't come for free. We do have to take certain things into account when developing software that will achieve this in combination with the cloud. That's what I'll be talking about. Let's contrast this with the design principles of Bitcoin, or most Bitcoin software, right? It's, of course, has a completely different focus for historical reasons, for ideological reasons. Self-sovereignty is really, really important. Self-custody is important. We want people to be their own bank. We don't want to rely on third parties. A cloud provider, of course, is a third party in this context. It's generally less complex. It's focusing basically on one user to run one piece of software on one node. But this is not going to work really as soon as we want to get into the realm of hosted solutions that end users can connect to with other devices than something that is authenticated to your home node. Right, so to reiterate, Bitcoin runs on a single computer instance at home. In the cloud, you have typically some kind of runtime that dynamically schedules your workload, like a Kubernetes or something like that. Bitcoin software assumes one user, and cloud assumes or generally wants to scale to end users. This is a really important one that I'll be talking about later also. A lot of Bitcoin software stores its state directly on disk, which is problematic for many reasons. In the cloud, it's encouraged as a best practice not to do that. And yeah, if you just have one user that you're serving and you're operating the stack yourself, it doesn't really make such a big difference if your software goes down or not. You will be fine. It's your money that you can't access, but it's not like you're responsible for other people's money. But if you're providing a hosted solution in the cloud, then obviously you want high uptime so that your end users continue to trust you, etc. So when does this become relevant, right? I think there's a kind of a scaling continuum here. From individuals to small merchants. They're probably the ones in this group that will be served well with their own node for the most part. But when you get a little bit larger into maybe sovereign organizations that want to do something like internal payroll or something, or larger merchants that have scaling needs, and ultimately commercial layer 3s like exchanges and stuff like that. I mean, you can't imagine an exchange just running one node on a on a Raspberry Pi or something. Obviously, this isn't going to work. So the point is here, it's a scaling continuum, And I think it would be really cool if we built our software that could serve more or less all of these purposes. That it's easy to run for individuals, but it can also be used in other contexts. I think, in particular, I think the biggest example of this where it's really critical is actually Bitcoin D itself, because Bitcoin D is our only reliable source of consensus software. And yeah, I mean, we've seen recently what risks there are when different implementations of consensus software are being run. So it is kind of important that we are able to run the Bitcoin open source stack in all of these contexts. So let's zoom in a little bit into what I mean specifically. Building for the cloud. Start off with a little timeline. At the bottom you can see the history of cloud becoming like a mature and established design paradigm for building software and software architecture. I guess it started with the public offering of EC2. That was the Amazon infrastructure as a service, where you could rent VMs. From there, fairly quickly, 1 year later, Heroku was launched, which immediately abstracted away all of the cloud infrastructure stuff and provided a very good end user being the developer here, UX, to be able to run systems, to benefit from the elastic scalability of the cloud without having to know a lot about managing the underlying infrastructure. But a couple years later, it crystallized out of the offering of Heroku this idea of 12-factor. It was a publication called the 12-factor app that talked about what kind of capabilities your application has to have, what kind of design principles you need to conform to reap the benefits, essentially. And I'll be talking a little bit more about those later. Around 2014, the cloud infrastructure stack started becoming more differentiated, and we started getting these scheduling runtimes that abstract the management of the underlying VMs and just provide like the compute resources to the upper application layers. And with the maturity of this architectural paradigms, of course, the CNCF Cloud Native Computing Foundation was founded to give a home to like open source projects that were being developed that were meant to help organizations building cloud native software by providing maintaining docs, conferences, etc., where people could get together and kind of figure out the best practices. And they've been around ever since, and more software gets hosted under CNCF. But to contrast that with the Bitcoin timeline, as we can see, like the Bitcoin white paper came out shortly after cloud became a thing, but it wasn't like 12-factor hadn't been published yet. So it's not very surprising, really, that Bitcoin D in particular did not take that into account when it was designed. It wasn't really known at that point yet how we should build software for cloud. It was kind of a parallel thing. But if you move on a couple of years, for example, when around the time that LND was created, LND is still very much from the application design philosophy taken a lot from how Bitcoin D works, rather than integrating the, let's say, best practices and learnings from the whole cloud native revolution that was happening in the meantime. And if you move a bit further on to today, we have now some hosted services like Voltage and Greenlight, which of course, to a certain degree, must exist because of the fact that these older Bitcoin softwares are just very, very hard to run in a cloud setting because they're not designed for it, and that from that the need arises to have something like hosted solutions. I think probably if it were easier, hosted solutions would exist anyway because of the faster onboarding, but it would certainly be less of a need if the previous software had been designed in a way that could better run in the cloud. And when you think about like not your keys, not your coins, that also applies to like sovereign organizations that also want to have custody, etc., but might have these scaling needs. So let's move on. Okay, what do we mean by cloud native? Yeah, I think I've already kind of talked about this up to here. It's about scalability in dynamic environments in particular. And ultimately, the 12 factors that I'll go into, their end goal is basically to minimize the user's operational burden. And I think this is also a key thing where there's a lot of overlap actually in what applications that are developed for the cloud want to achieve versus applications that want to be run on a Raspberry Pi, for example. And that is ultimately the user experience when you're operating it. You don't want to spend time operating your software. You just want it to be reliable. And I think this is a place where there's a lot of learnings to be had. All right, let's jump into 12-factor. I'm not going to talk about all of them, but many of these have spread widely through the software industry by now, and have also become best practices in Bitcoin space, like how code bases are organized, dependencies, config, etc. I'm not really going to talk about this. Here are the ones that I do want to talk about: backing services, processes, concurrency, and disposability. I think of the 12, these are the ones that Bitcoin software has adopted the least, unfortunately. And yeah, to run in the cloud, ideally, to make it seamless, you really need all of these. So backing services, the way 12-factor talks about backing services is it takes the assumption that your main process, your application process that hosts the business logic will be stateless, and any kind of external state that you want to access needs to be done via an attached resource. That means you have basically like a HTTP connection or something, or a networked connection that by which you can consume, for example, a database service that you can then use to store your state externally. This is so that the main application remains stateless. Just one more thing, you have to understand, if you don't do this, I think there are some arguments to be made maybe that you want state on disk for some things, but you just have to understand, when you're doing that, you're basically saying to your end users, I'm able to maintain a database. As soon as you write state to disk, your software, even if it provides a different kind of use case, you're basically taking on the responsibilities of a full database. And that's really, really difficult. I mean, you can use embedded databases like an SQLite, but still you have scaling issues. So yeah, I don't know, just don't try to be a database, I guess. Anyway, okay, processes and concurrencies. This is also pretty important. The scaling model for 12-factor assumes a unit of scale of the process. And if you have different things doing, like if your application is made up of different functional aspects, then the recommendation here is actually to have different processes and scale that way. And in particular also concurrency. If we need more compute or more resources to be consumed to provide the end user experience that we're looking for, then the model of scaling is to replicate the processes. And that way, yeah, you just don't have to deal with like where is state going, or like scaling in place is just a lot more tricky. If you have to like change out the, I don't know, CPU of your VM versus just adding another one. All right, and last one I want to talk about, disposability. So this is the famous in the DevOps space, and now also coming to other people, analogy of the cattle versus pets, right? I think this is really the most obvious in terms of Bitcoin. Like, if you're walking through the halls, like how many people are going to ask you like, oh, my node has a channel with your node? Okay. Oh, I don't have liquidity here because this channel is broken or whatever. So we're talking about pets here the whole time, right? You could give your LND or your Bitcoin D a name almost, like, yeah, that's my little Raspberry Pi. There's even this meme that Jameson Lopp always says, like, this is my gun, no another like it, and he appropriates that for Bitcoin, etc. So this is like exactly what we don't want, essentially. If we want to write a system that can scale, we need disposability. I know it's a little bit macabre, but cattle in the sense that you just don't care what individual process is serving your purpose. You have a bunch of them, a pool of them, and somehow your use case will be fulfilled, but you just don't care. That's generic. All right, so this is kind of redundant, but as you can see, the two most widely adopted pieces of software in our space don't stack up very well. Oh, I think, oh, I forgot to do this. I guess my presentation wasn't quite ready. So public cloud versus private cloud. I think here I just wanted to reiterate there is some overlap between like the needs of sovereign individuals, for example, and sovereign organizations. They might want to keep their nodes, keep custody of their funds, etc. And there is this thing called like private cloud. So just because I'm saying like let's build software to be run in the cloud, it doesn't mean it has to be hosted like on an AWS or a GCP. This can totally be useful. You don't have to give up the security aspects of what the Bitcoiners want to run at home just because you're going to build software that can scale. It's not a trade-off. Okay, final thoughts here. What can we do accepting the realities of how it is? Well, if you want to start building a system today that you think might survive some kind of growth and might want to scale, it's going to be pretty hard with the existing open source software, but you can use one of these hosted solutions that I've already talked about: Voltage, Greenlight, LNPay, OpenNode. These are Galoy, of course, too. These are like hosted solutions that will just take that burden off you, and you can pay someone else to have the pain of running these systems, I guess. Capabilities to focus on, like if you want to build something that will integrate into this larger Bitcoin stack, and you're thinking like, well, I want to do it better. I want it to work in the cloud while not trading off any of the things that Bitcoiners like. I think these are a few to focus on. There are other ones, but I think these are probably the biggest one. Stateless processes. I've talked about that now. Just put your state in a database, please. Thank you. Okay, let other people deal with scaling the stateful aspects. Tracing. This is also really important. Like if you're writing a distributed system, operating a distributed system, you need to be able to see what's going on. Logging is just like one-dimensional. It only shows you what's happening in one process. Tracing is the only thing that I know of that will give you insights across many network hops within a distributed system, and it's really not very hard to integrate. You have, just like you have logging libraries, you can just add a tracing library instead, and you can just have the log output locally into the console if you're developing anyway, just by streaming your traces locally. It's not like any more or less painful than working with logs, but the difference is if you have this as a first class principle, you're just helping so many people that may want to run this in a distributed context, in a scaled context. And packaging also is something I've noticed that is not often a first class concern in a lot of systems in the Bitcoin space. Just like an official Docker image maybe, or if you want to go even a little bit further, maybe an official Helm package would go a long way in getting your software adopted and used ultimately. Okay, so yeah, conclusion, we're not quite there, but this is fine, and happy to take any questions. Please. That's a good question. So the question is, are we going to be working on bringing the existing software into the cloud, or are we going to have new implementations? And I think, well, I mean, with Bitcoin D, it's really, really difficult. Like, I don't see a way that we should write like a cloud-native Bitcoin D, because the consensus software is just, we've seen historically, it just has to be the same. So I think for Bitcoin D, the solution will most likely be to not use it to like process payments or anything, but just use it as a block source and have multiple ones of them. So treat it essentially as yeah, like not to host your keys. Treat it as an like a not critical part of your business logic, but have multiple ones so that your applications can just fail over like where they get the blocks from, essentially. So I think that's the way to deal with Bitcoin D, but not like use it as a host for your hot wallet keys, for example. That would not be right. For the Lightning implementations, I anticipate, since they don't have the same issues with consensus criticality like Bitcoin D, I anticipate that in the next years we will see other implementations that will be more geared towards like enterprise and scaling use cases. That's my assumption. Yep.
Hey. Hey, where do you think like key management fits in the stack? Like, is it like a 13th element maybe, or like with paradigms like voltage? It's like you have to think about like if you're running nodes for users, then you have to secure cryptographic material without actually storing it anywhere, and that I'm thinking of like how it fits into like the cloud like ecosystem. Like,
sorry, could you repeat the first one? Key
Yeah.
management? Is
Yeah,
what you were
yeah,
talking-
like
okay.
private key management and like authorization of infrastructure that you don't have access to directly.
Yeah, got it. I think that there will be a variety of solutions. It will be also kind of a continuum on like custody is completely co-located in the cloud versus you have like observer wallets, but you have the signing in a different setup. So when you separate the signing, I mean it's pretty clear that it's going to go this way, that you're going to separate the signing from the from like the observation, let's say, and then the question is, well, what happens with the signing? How does that need to be scalable? Does that need to be resilient, highly available, tolerant, right? So is the signing itself also a cloud system that you put on your private cloud maybe, or can it just run on your single node or whatever? Like I don't know. Like there has to be some redundancy also for the signing, but I'm pretty sure that it will evolve, that this will be two different environments. Yeah, I have time for another question if there is any more.
Yeah, I have a question, because LND has supposedly an experimental mode that you can use etcd for the storage. Do you have any insight if that's how it works? Should be scalable enough, I mean, for multiple nodes running concurrently?
Right. So in our experimentations with these kind of LND features, we've come to the conclusion that it's not really ready. I would say there's still scalability issues with it. It's the difference in writing like a cloud native system from first principles and deciding like this is going to be a key constraint